Hi. Now, if we take an area trapped between several curves and spin it about the y-axis, then we generate a solid of revolution. And if we were to just look from above, you'll notice that we can see the hole in the bottom. And if we look from below, you can see the hole below. Now, in this video, what I want to do is show you then how we can work out the volume of this particular solid of revolution. So, to work out this solid of revolution, what we do is we take this area here, trapped between the curve y equals x squared and the lines y equals 2x and y equals 1. We take this area and we spin it about the y-axis. And what we get is this solid of revolution. You can see what I've done is just tilted it slightly so we can look over the top and see the hole at the bottom. And also I haven't completed the solid of revolution here. What I've done here is I've just left it slightly open so that you can see this cross section here, which is the one that I've shaded up here. So when it comes to working out this volume then, we do it in two parts. What we need to do is find out first of all where these two curves intersect, that is y equals x squared and y equals 2x. I'll just draw a line across here. We'll find out where that point is in a moment. But then what I need to do is work out the volume generated by the curve y equals x squared about the y-axis between y equals 1 and this value at the top here. And from this, subtract the volume generated when I spin the area bounded by y equals 2x, the y-axis, and the lines y equals 1, and whatever this value is up here. So we'll just say that this is equal to this volume then, V1 we'll call it, minus this volume generated, which we'll call V2. So we need to find out this y value here. Okay, it's the point where y equals x squared and y equals 2x intersect. So if we're going to work out that point of intersection, let's just put a subtitle here, intersection. And that means that we've got to equate x squared with 2x. So x squared would equal 2x at that point. And in the usual way, I'm going to subtract 2x from both sides. And so we get x squared minus 2x equals 0. Factorize this, and we therefore have x as a common factor, and then x minus 2 in brackets, and it equals 0. So that would mean that either x would equal 0 or it would equal 2. Okay, when x minus 2 equals 0, x would equal 2. Well, clearly this is the point that we're interested in. It's when x equals 2. Not this point, that's the point when x equals 0. So we need to find out what the corresponding y value is when x equals 2. And we can substitute it either into y equals 2x or x squared. Either way, you're going to find that therefore y equals 4. So we now know that this y value up here is going to be 4. So we're going to need to work out our volume between the limits y equals 1 and y equals 4. We'll pop it in there as well. Okay? So when it comes to working out now, let's just border this off first of all. But what we're going to do then is work out this volume V1. And we get V1 by applying the formula for the volume of revolution about the y-axis, which we discussed in an earlier tutorial. Remember, it was pi times the integral of x squared with respect to y. And in this case, the limits for y are going to be between 1 and 4. So I'll pop those in there. So for this one, x squared is equal to y. So therefore V1 is going to be pi times the integral going from 1 to 4 of y with respect to y. And if we integrate y with respect to y, that's going to be y squared over 2. I'm going to pull the half out the front, okay? You don't have to do that, but I just think it's easier. So what we've got here is y squared over that 2. And it's going between those limits 1 and 4. So if we substitute these values in, we've got pi over 2, and then we've got 4 squared, which is 16, and then minus 1 squared, which is minus 1. And that's going to give us 15 pi over 2. So there's our volume then, V1, 15 pi over 2. And we'll just put that that's units cubed, being a volume. Okay, let's come down here now and work out the second volume, V2. So for V2, same way, it's going to be pi times the integral of y going from 1 to 4 of x squared integrated with respect to y. We've got to get this in terms of y, and I can see that from this x is equal to y over 2. So we need to square that, and we've got pi then times the integral going from 1 to 4 of y squared over 4. I'm going to take that 4 out the front, okay, just to make it a little easier to work with, and we're integrating that with respect to y. So what we've got here then, if we integrate y squared with respect to y, we're going to get y cubed over 3. So 4 times 3 is 12, so we've got pi over 12 multiplied by y cubed going between the limits 1 and 4. Substitute our limits in, and we've now got pi over 12 multiplied by, well, we've got 4 cubed, which is 64, and then we've got minus 1 cubed, which is 1. 64 minus 1 then is 63. 63 pi over 12. You could divide top and bottom by 3, and this reduces down to 21 pi over 4. And again, being a volume, we'll just say that that's units cubed. So this puts us in a position now to work out the final volume of the solid. So therefore, we can calculate the final volume. We'll put therefore volume equals, and all we need to do is subtract our two volumes. That's 15 pi over 2 for this volume, V1, and from this we subtract 21 pi over 4. And what we get is 9 pi over 4. And that's our volume then of our solid. 9 pi over 4 units cubed. Okay,